morning. Thank you for joining the August 9th, 2018 VOLTHA call. And we have a couple presentations and discussions planned for today. So do keep in mind that we record these, so keep that in mind when you're doing the presentations and during the discussions, because this will be posted to YouTube later on. And with that, I think we'll just quickly look at the agenda. I should be sharing that on my screen right now. So the first topic for today is a review of the updated core adapter interface proposal from Ken. That's been out there on VOLTHA Discuss for review for a while. And then after that, we plan to have a presentation from Nick related to the discussion that started on Tuesday related to acting directly on logical flows instead of the device flows. So we'll start off with Ken's proposal. And Ken, are you ready for me to give you presentation rights?
Yes.
All right. The change presenter. All right, you should have presentation rights now. Thanks.
Okay, let me share the whole screen. So can everyone see my screen?
Yes.
Yes.
Okay. So basically this I wrote an API document and API interface between the core and the adapters. Now that the adapters will be in their own containers. So this presentation is really about how the two will communicate together. Like here on my screen, I'm showing a diagram, a picture of one of the presentations I had before of how the core and the adapters will communicate over the Kafka bus. So currently, the two remain in the same container, like adapters and the core, they're on the same containers. So what we have an interface called the adapter agent. And the adapter agent is the one that the core talks to, and also the adapters talk to that adapter agent. So it's really the middleman between the core and the adapters. But today, it's just a simple class. And since it's all reside in the same containers, it's they each talk to each other without any issues. So now that we are going to move things, the core in its own containers and adapters in their own containers, so we have a Kafka bus in between. So we need to be able to have two sets of interfaces totally separate from each other. So the adapter agent that was there before now suddenly become two. I separated that into two. One, I call it an adapter proxy that the core will talk to, and another one is a core proxy. That's the adapter will talk to whenever they want to talk to the core. So the code, like the interface, the API that I'm going to show, would be the core proxy and the adapter proxy. Obviously, like those API has to be implemented on each side. For example, for the adapter proxy, inside the adapters, whatever APIs I'm presenting needs to be implemented. And the same thing for the core proxy, whatever API I'm presenting needs to be implemented inside the core. Any questions on that? Okay, so this is a document that I circulated a while back. First, can everybody see the screen?
Yes.
Okay. So this is a document I circulated a while back to show those interfaces. Like I mentioned, like before, there was these two interfaces, iAdapter interface and iAdapter agent interface, were all implemented in the adapter agent, and those were used for the core and the adapters to talk to each other. So what we have in this document, I'm not going to go through the first page, but basically I'm going to go directly to the iAdapter interface. And one thing of note is when I built that document, that was a while back before we switched the core into the Go language. So some of the APIs that you're going to see will change. Not the one that the VOLTHA will talk to the adapters. So the adapters APIs per se will remain as is because they conform to the twisted format, the Python format. But the one from the adapters into the core they will change. Basically, a lot of them will remove the underscore and be camel case, because that's how Go language use things. So first of all, I'm going to show the interface, the one that represents a VOLTHA adapter. Basically, this is a VOLTHA adapter interface. All those interfaces in this document, they're classified as API that currently are being used, that have not been changed at all. I'm going to show the API that have modified, that will change maybe the signature or the meaning of it. There are API that have been deleted, that are no longer relevant, and also some new APIs that has been added. So I'm just going to go quickly over each one of them, and please throw in your comments anytime, but I'm not going to go for each API. I'm just going to go for a gist of things. So the first set is the end-change APIs. Those APIs are what exists today. Those are the API that core talk to the adapters, to each adapter. So those doesn't change. For example, things adopt device will remain as is. That doesn't change. So there's a whole slew of them that are not modified. They remain as is. So I'm just going to go quickly to the one that are removed, that are no longer required. For example, currently, when an adapter is loaded, the core will invoke it to start or to stop. So we no longer need to do that, because the adapters will live in their own containers, so they can start and stop on their own. And there was an API to change master state. We no longer need to do that. It should be controlled by the adapters themselves.
One thing is,
go ahead.
Even though the core doesn't handle the start and stop, does the core need to know whether or query whether the adapter is up and running?
Yes, there are two ways. We talked earlier in the previous presentation how to do that. One is that we communicate whenever an adapter comes up, it registers itself in the KV store under a list of adapters. So the core will listen to that. We'll have a listen on the KV store and the adapters and figure out what are the adapters that are available. That's one way of doing it. The other way would be for the adapters when they come up, they send a message on the Kafka bus, and then they add to a specific topic of the core, and the core will listen to that and know that the adapters are ready. We have not figure out like which one is the best approach at this time, but those are the two approaches. So yes, the core will need to know which one are available, and if for some reason like the core doesn't know and send a message on the Kafka, there's always a timeout for those requests. So whenever we send a request, it's we're not getting any responses back, then there will be a timeout for that. Does that answer your question?
Yes. I just wonder whether, maybe there's a user story need to cover this, discover or, hello, that kind of the scenario. Okay.
Okay. So, and there are some others that, some other APIs that no longer need, like send a proxy message. Usually those were used from the core, from one adapter to send a proxy message to another adapter. So there's different APIs for that. So those are no longer required as is. So I'm removing that. The proxy, obviously send and receive proxy message are being removed. And there was receive into adapter message. Those are being removed. There's a different set at the end of this document that is there. And then there's a lot of APIs that were for expand, like create interface, update interface. So all those APIs are removed for expand. And the modified API, one of the modified is API that from the core, when it's invoke the adapters, one is to send a packet out information. Currently, when we send a packet out information, we send the packet out information with the logical device ID and the egress port number and the message. Since the goal is to move the logical device concept inside the core, for the core to manage that instead of the adapters to manage that, so I'm changing the API. Instead of sending it to a specific logical device ID, we're going to send it directly to a device ID. So that's a modified API. And in terms of new API, again, since the core is the one responsible for logical devices, so currently what we have, the adapters, when they discover in OLTs and then eventually the ONUs, and they are the one that create the logical device ports and everything. For the core to be the owner of that logical devices and do the management of that, so they will need to own the full life cycle of logical device management. So, but there are some information that it needs from the adapters to be able to create those logical devices and those logical ports. So here I put two different APIs, one to get the OpenFlow device information and one the OpenFlow port information. So it will need that. So the core will make a query to the core to get to the adapters to get those information, and then it will create those logical devices and logical ports.
So this one has, I think, if I remember correctly, Nick was talking about, or someone else was talking about the logical device to be created by the adapter. But right now, I seem to remember that kind of discussion. But with this API, it means the core would create the logical device for the OLT. What about ONTs?
This is Nick. The idea was not so much to have the adapter create the logical device, but more, my proposal is more about the flows, the logical flows.
Okay.
The device can be created by the core. I'm fine with it.
Okay. And Ken, so this logical devices, does it also include the ONUs?
Well, logical devices represent pretty much an OLTs, or
OLT.
Eventually we can move it to be an aggregation type of device where you have an aggregated device where you have a lot of OLTs attached to it. We can move to that kind of concept, and the ONUs will pretty much be logical ports.
Okay. Okay. Yeah. Now I see the OLT only. Okay. Great.
So the NNI ports for a given device, like an OLT device, I mean, how are those defined? Is there a default set of NNI interfaces defined, NNI ports for an OLT?
Default, like you mean, like currently we support one,
So if I create an OLT device, right? So I create an OLT. Right now, there's basically a single NNI port that's created for that OLT device, and then as ONU unis are notified that they have come into existence, then we create those logical ports for those ONU unis, right, dynamically. So if we wanted to have an ONU with, I guess more than a single NNI port, then we'd have to have some way of controlling that, I guess, when we create the OLT itself, right?
But do we want to have only one NNI port? Right? In the core, we want to be able to support any number of NNI ports.
Yes.
So basically, like you'll see it like because this is the request from the core into the adapters, and later on you will see the request from the adapters into the core, and pretty much one of them is like a port added event that comes into the core. And that port added event can be an NNI port that has been added. The physical NNI port has been added, and the core will translate that to create an OFP NNI port for that logical device. So you can have multiple of those events that are coming in. And based on those events, we'll be creating those logical devices and logical ports. Make sense?
Okay, so when I create an OLT from the CLI, for instance, then it has 0 NNI ports, or it just has a default 1, and then it gets notified from the physical OLT about any new ones.
So it will have 0 NNI ports until you get notification from the. There's no default.
I see.
And one thing I forgot to mention at the start of this meeting, like this document is a live document in the sense of as we start to do implementation, and some of those interfaces may be modified or may be added, or new ones will be added, or because it's we are changing things from the way it's been done today to a new way, and the chances are, like at this time, since no implementation has been done on those APIs, chances of things will be changing as we go on. So we'll just keep that in mind. But the whole gist of it would be like the idea of it will still be there. It's just like maybe there will be slight modification in
there. If ONT is the port of a logical device, what is the interface of ONT? Is in a logical device?
For the ONT, it is represented by a uni open flow port. The entire ONT.
Yeah, the uni is a port, or
on the logical device, like if you take a logical device, you have the NNI OF open flow port, and then you have the uni open flow port.
Okay.
So the uni represent the ONTs, and the NNI open flow port represent the NNI ports on those OLTs.
Okay.
I mean, there may be more than one uni on a given ONU at some point, right? I mean,
yes, absolutely.
Yeah. Okay.
Just like there can be multiple NNI on the OLTs.
So Ken, as you said, this is a living document, so it can be modified and changed based on the development, right? So is there any way we can do a tracking on this document so people can tell the differences?
Yes, like we can do the tracking on this document. Like this is the second version of it. I didn't do any tracking on it. The reason was like I started to do tracking and it was getting so messy because there were so many changes. So I didn't do that. But going forward, I'll do tracking on it. And every time we do
I think once you have an initial baseline, then we can start doing that, right? Okay.
Yeah. Okay. Any other question? Okay, so now I'm going to the other interface. This is that interface represents a VOLTHA core. Pretty much like the adapters will be invoking those APIs whenever they need to talk to the core. So there's a bunch of the same. There's a bunch of API that doesn't change. Like for example, get device, get child device, get ports. All those are not changed. They remain as is. There are APIs that are removed, and some are removed because they're not used. For example, like add device is not even being used. There are some that were used to send for the adapters to talk to each other. So those are being removed, like all those publish, subscribe, all those ones being removed. There are some that are removed, for example, submit KPIs, submit alarms. Those are removed because currently the adapters, whenever they need to send a PMs or an alarm, they invoke a class in the core, and the core is responsible for sending that on the Kafka bus. But going forward, the adapters will be able to send those KPIs and alarms directly on the Kafka, so they don't need to go through the core. So that's why those APIs are being removed, like submit KPIs, submit alarms. There is some that were not really being used by the adapters, like register for ONU detect and all those things. So I just removed them because they're not being used. There are some that were duplicated, so I removed them, like child device detected. This one, this reconciled child devices. And this is pretty much like a message that was being sent from the OLT to the ONUs. So that can be done directly on the Kafka. So we don't need to go through the core for that. There are some that have removed pertaining the logical device, and those are the one that I'm not so sure whether we'll be able to remove all of it or part of it. And I think some of it is really during development, or maybe you folks already know some of the APIs that you will absolutely need. Pretty much is because the core is responsible for all the logical devices. So does the adapters needs to know anything about the logical device? I guess there will be some cases where it will be like with Nick proposal to have flows in the adapters, then maybe they will need he will need to know about the logical device. But for now, anything where the adapters were requesting any information about a logical device or port, I'm removing it, and just for now. But we can argue whether the adapters will need them or not. Like get logical device, get logical ports. Create logical device, definitely that won't happen. Reconcile logical device, delete, add, port. All those has to do with the logical device and port. So we'll see whether we'll need them or not. There are a bunch of them. For example, they were like more regarding device management, like peer reference, port reference, those are really like how the core manages the connectivity between the OLTs and the ONUs and the logical device. It's an internal structure, how it does that. So there's no point of having API exposed for that. So that's those are gone. So in terms of modified APIs, most of the API, per some of the recommendation, I think some of them were from Jono. It was try to make the APIs from the adapters into the core, try to make them more like event-based instead of command type of base. For example, instead of the adapters calling in says add ONU device, the adapters needs to say it detect a child device. So instead of having add ONU device, now it's child device detected. It's more in the naming of things. So there's a bunch of them that has been changed. For example, like update device become device update, delete child device become child device removed. So there's a number of them. Like it's pretty much the same API. It's just like the name has been changed. We have a bunch of them. For example, add port now is become port created. The port has been created. We have port removed, port enable, port disable.
So is there a way that the core can reconcile what its view of a device might be with what the adapter thinks it is? I mean, like is there a way for it to read state from the adapter?
Read state of the device?
So like, let's say a core comes up, restarts, and it sees that it has an OLT device, for instance. Is there a way for it to reconcile what the device state is with what it views the state of that device as? I mean, so it could be used for an audit, it could be used for like a restart situation for the core. if there's no record stored about what that device has, is there a way to see what the current state of that device is?
Like a little bit similar to what we had before, like the reconcile command. Something similar to that, right? Is that what you have in mind, or just a command that would come from the an API card from the core into the adapters? For example, something like update device. Is that what you're thinking, or? Sorry, can't hear you.
Sorry, I was on mute.
Okay.
Yeah, so if we're moving from this CRUD model where I have the ability to read, if that goes away and now I can listen to what the device tells me, but I can't actively go and read it, have I lost the ability to do an audit or to do to reconcile what I think the state is with what the device is?
No, the get ability will still be there. It's like
okay.
The event is more for cases where actually it should be an event instead of a command. Like, for example, the core will still need, for example, in the case of reconciliation, well, it will need still to send a command to the adapters. And vice versa, if there's something that the adapters absolutely need the core to do, then it will come in. But in many of the cases, what we're saying is the adapters is doing something. It should really be an event that's coming into the core. So in cases where it should be an event, it's an event. Otherwise, it will be the
yeah, and that's fine as long as the core and the adapter are there on day 0, right? But if the core comes along at day T plus whatever, right? It still needs to figure out or reconcile what its view of the device is with the device, right? So as long as it has the ability to get that information, that's fine.
Yeah, absolutely. It should have it, and if it's not part of those APIs, needs to be added. So let me see what else in terms of. There is an API currently called create alarms. I'm changing it to create event because alarm it's whatever comes from the adapters or even from VOLTHA, those are events that a northbound system needs to interpret as alarms or not. So I'm just changing the name of it from create alarm to create event. And in terms of new API, I don't see any new API to add it. There could be, if as we're developing, there will be new API that the adapters will need. At this time, I've not put anything there. And what else in that document? So this is I put a new class. It can be any class name, but pretty much this is for the adapters to talk to each other. Like I have a send into adapter message. This is for an adapters to send a message to them. It's pretty much the same as a proxied message that was there before. So I replace that. I have a send into adapter message and then receive into adapter message. That will be the other end that will be receiving that request. And what else?
Hi, Ken. I had one comment here. I shared that earlier in the mail. So, yes. So if the core is sending a message and the cluster of adapters, is that possible? And how would the core identify the instance in the adapter cluster that it wants to talk to?
Okay, so there's different ways of doing that, and I've not settled on one specific way per se at this time. So basically, like everything is going to go through the Kafka bus, and it will go on a specific topic. So every single adapters, for example, like PwnSim OLT, it's an adapter, so it will have a topic called PwnSim OLT. PwnSim OL new will have another will have a topic PwnSim OL new. So like for the OpenOLT, it will be the same thing. For iTran, it will be the same thing. TBT will be the same thing. So everybody, all the adapters will have their own unique topic. So this is for the call to send generic message to them. Now, if we want to have the case where we have an OLT responsible for certain, not an OLT, an adapter managing a certain device, and so if the adapters themselves support HA, for example, you have two adapters and both of those can handle requests both from northbound and southbound to the same set of OLTs, then what they will need to do, they will need to create a topic with the device ID. Now suddenly when they send a message down, it will be sending on that specific topic. Then both of those adapters, if they are like supporting HA, then they will get a message and then process for it. Does that make sense?
Yes, it makes sense if we use a unique topic per device ID. Yes. Yeah, thanks.
So here at the end of the document, like this, I will let you guys go for it. Pretty much, this is, I started to do the device state machine in the core and see how that will work. Let me see if I can make that a little bit wider here. Look at my screen, it's not showing. Okay, so this is I started to build the device state machine. It's not completed. So pretty much this is a table that shows like the actions that the core is going to take whenever we get certain events. For example, like when we're doing pre-provisioning, it's come from the user. At the beginning, there's no states on the device. So the core will create a device, will put it in pre-provisioning state, and then nothing happens. When we do enable, then we change the state, we send a message, the adopt device to the adapters, and so on and so forth. So it's a bunch of states and transitions, and that I put in here. So I invite you to look at it. I have a bunch of questions also for folks. So it's please go over it and let me know like whether some of it makes sense or not, because it's if we go for each one of them, it will take forever. So it's I think it's better than by each one reviewing it as per your adapters and figure out whether it makes sense or anything missing, and then we can either have another meeting or we can do it over VOLTHA Discuss. And that's pretty much it what I have for the API. Any questions?
Yeah, nice job, thanks.
Okay, thanks.
So your post 1.1, right? This is version 1.1 you're displaying. I think yes. The one on the, okay.
Yeah.
So is there API to apply a logical flow to the adapter?
To apply?
Yeah, to configure the flow data to adapter.
Yeah, there are APIs. Like those are currently in this document. It's the existing API. It's not changed at all. It's somewhere. It should be there. Well, you see update flows incrementally, update flows bug. So those, I leave it as this. I've not changed the API per se. And those will be, we'll figure it out after Nick presentation. Maybe we need to add things there or maybe remove some stuff, we'll see.
Okay.
Other questions for Ken? All right. If you can, I'll go ahead and temporarily take presentation rights back.
Thanks.
I can get my controls to work here. Okay, hopefully we're seeing the agenda again now. So Nick, I think I did see you on the bridge. Do you have a presentation you'd like to share for the second topic for today? All right, are you ready for me to give you a presentation, right?
Yep.
Okay. And you should be set.
Okay.
Yes.
Oh. So, yeah, so my proposal is about the flows and how we interact with the flows. So I'm going to go briefly into the current to get everyone on the same page. If I get something wrong, don't hesitate to stop me. I think I got at least the most important piece of it. I'm going to show my proposed model and then show them side by side on different voltas. So in the current model, usually you have ONOS sending open flow messages to add flows to the OF agent, which is then interpreting, wrapping them up, translating in gRPC, sending to the local handler, and then the local handler is adding into the VOLTHA knowledge through the config proxy, which is updating the data store. It's not really important for things, just for completeness. Then the red arrows are callbacks. On update of those logical flows, there is a callback going to the logical device agent, which is going to decompose the flows and then add those decomposed flows back to the config proxy as device flows to the various device IDs, namely the OLT side and the ONU side. So those device flows, as represented on this side for the OLT and this side for the ONU, are then detected by callback by the device agent for OLT and for ONU. It results in a update flow table command with those flows to the adapter agent, which then goes to an update flow table to the adapter. The various adapters. FYI, the colors, blue is the VOLTHA piece, different colors, different containers, and the round edges are core elements, and the adapter agent is kind of in between, and the more squared shaped thing are the hexagonal are the adapters. So this update flows go to the OLT, which is going to do an interpretation of those flows and update the flows through whatever protocol to the physical device OLT. On the ONU side, the ONU is going to interpret the flows, send some OMCI wrap to the OLT adapter, which is then sent back to the OLT, then to the ONU to be configured. Does everyone agree on the current model as it is presented?
Yeah, I think so.
Okay.
It's very good.
So that's what's happening now. My biggest problem with it is the decomposed flow in the logical device agent, which makes the same decomposition regardless of the underlying implementation, and then which is storing the flows the same regardless. My suggested model as the same beginning, ONOS, OF agent, local handler, the logical flows are added here into the data store, its CD console. The callback happens all the same to the logical device agents. However, the change in green here, and the logical flows differential, and it's not only the logical flows, it's only the changing flows, are sent to the OLT adapter. The OLT adapter is doing the decomposition based on its knowledge of its capabilities. It's decomposing both for himself and for the ONU adapter. Then it's sending its flows to the OLT, storing a representation of what he pushed to the config proxy, then there is still this callback happening, but it's grayed out because nothing is happening in this to this regard. I mean, I cut the link over there. And then the OLT adapter will send the rest of the logical flows, the one that he cannot honor himself. For example, he's honoring like the first of the two tags, like the S tag, and he's asking the ONU, you honor the C tag, for example. Sending the logical flow to the adapter, the ONU is interpreting those flows, and then sending back same ONCI back to the device, the physical device, and storing the flows it has pushed to the config proxy. So the main difference here is that the adapters make the decision about how they split the work, and they store what they deem a correct representation of the flows they've pushed. Because depending on the adapter and the underlying hardware, the implementation of such flows vary, maybe a lot. For example, in one case, what can be 6 flows in one adapter may be 8 in another one. And for troubleshooting purposes and operating purposes, it's better to know how many flows have been pushed, to know what's the baseline. If for this adapter, I'm supposed to have 8, but I notice that I only have 7. If it's not working, it's because I'm missing 1. Whereas if I have 6, regardless of the adapter, and just one flow failed somewhere, I don't see it. There is no, in the current model, you do not see anything that was actually pushed. You see what the logical device agent think you should push, but you don't know what was actually pushed. So there is a gap of knowledge between what should have happened and what has happened. If you have any question, I'm going to take them now, or I have a demo side by side of those two things, so you can see what's the actual difference in from the operating perspective. If you rather me start with this,
Hi Nick, just a quick question. Like when you mentioned in the current model, there's a gap between what's being pushed and what actually being shown. That can easily be rectified by doing the same model that you're proposing, where after the OLT and ONUs decompose further the flows in the current model, they push back the result. That can be rectified that way as well, right?
But to do that, the thing is, at this point, once the flows have been decomposed, they're already stored as the device flows. And then the OLT is going to try to push them. We could catch failures and then remove them, but then they will not be repushed on another try. I mean, the linkage is fairly complex to this regard. That's somewhat my problem to handle failures. And there is also the question of removing flows. Since you don't know, since those flows in the current case are decomposed and stored over there all the same all the time, they have no bearing whatsoever to what I call the whatever protocol here, being gRPC or layer 2 something over here. Whatever the OLT adapter has to send, whatever commands it really has to send, most commands, I mean, at least in the OpenOLT case, I'm sure in the others, they have to send a flow ID, and they may not be able to use the same flow ID that's over here, especially if one flow that is decided over here results into 3 flows. Now you need to store some kind of mapping to know that if this one flow is removed, I need to remove those 3 flows. And by having the adapter storing its own flows, I mean, those 3 flows are now described and fully accessible. You can store the actual IDs that are pushed over there. And in my case, I used the cookie to override the cookie concept of the OpenFlow thing to just use the mapping from the ID of the logical flow over here to the cookie of this flow over here, just to be able to know that I'm removing this flow with this ID, I'm looking for those flows, those device flows with those cookies, the same cookie, and I know when I get those IDs and I remove them from the OLT. I hope it answered your question. Otherwise,
no, it's
I need to read it again.
Answers my questions. When you mentioned about cookies, cookies are not unique, right?
They're not. They're not, and in this case, they will not be either, because one logical flow coming with ID 51 may result into 3 device flows. So you'll have 3 device flow with cookie 51 that maps to this one, but the ID of those device flows will be unique.
Mm-hmm.
The cookies is more like a helper thing to not. We could use something different, but since we're storing currently open flow objects, I had to find something in this that I could use for linkage, and the cookie seemed to be a decent choice.
Okay, so the whole idea of having originally to have the flow decomposition in the core is to have a uniform model so that the adapters each adapters don't have to create their own decomposition.
True, but
do you see a case where the part of that work can still be done in the core, and so that some basic adapters can make use of it? And then
I think we could make a common, like a sample decomposition, if you will,
mm-hmm.
that could be reused by adapters. Like we put it in the extension part of VOLTHA.
Mm-hmm.
So let's be like the cookie cutter one.
Mm-hmm.
People building the adapters are free to use it or not, or amend it in some ways. But I don't think we can assume that all adapters will implement them the same. And my biggest gripe is that we have logical flows that describe something, we translate them regardless of the implementation or anything, and then we pass those down. So we've gained 0 information from one step to the next, and we've just take some set of things, translated in something exactly independent of the receiver, and then we send this to it. So we just we add a middleman that has no purpose in my mind. Because this standard decomposition you're mentioning in the core, I mean, to some extent, it's already done in ONOS. It's a standard decomposition of the flows. I mean, a standard set of flows to do one thing, and then they're interpreted a different way.
Mm-hmm.
And it could also lead to have some adapters being able to implement different set of flows in ONOS. For example, if we were to do something like a VXLAN tunnel kind of thing, or something a bit crazy, ONOS could send such command, and the OLT adapter may be able or not to implement those things, depending on the underlying hardware and capabilities.
Mm-hmm.
I think we have to be careful that we can't let the adapters generate different, I guess, OMCI configuration or different implementations for the same flow. I mean, 2 different adapters have to come up with the same operations from a given flow, right?
I mean, they cannot necessarily have common implementation if they have different hardware, different underlying hardware.
No, but what I mean is, if an ONU is adding a tag, and the OLT is adding a tag, that can't be different between 2 OLTs and ONUs.
No,
right?
but the idea would be the OLT decide, for example, I deal with both tags. You just send your traffic.
Well,
for example.
That
could be a choice.
That won't be standard, though. I mean, that won't be standard. The one OLT has to. From a black box perspective, if I view the OLT NNI and the ONU uni, right? I mean, the inputs and outputs have to be identical.
It doesn't break this piece of it. If assuming standard case, the OLT take care of the S tag, and sending the logical flow, the remaining logical flow, to tell the ONU, you add yourself this tag 20, and you send it upstream. And on the way down, you reverse it. And then this ONU adapter create the OMCI and send it to do exactly what it was told. And that's it. And if we have a different implementation of an OLT that wants something different, it wants maybe the ONU to come up with 3 tags and the 3 different T counts, so many gem ports. Those flows can be pushed over here.
But ONUs can be managed by different vendors' OLTs, right? I mean, you don't want
they could. Yes. I don't think there'd be a problem if the OLT give the ONU a clear command, like add an S tag and up, which is what we usually use for now, and the ONU is implementing this command faithfully with the proper OMCI, it all works. If the OLT gives a different set of commands and the ONU still implemented faithfully, it still works.
No, but if I do, if I have type B protection, for instance, right? I mean, if one OLT is expecting the ONU to add the S tag and the other OLT is not, then that's not going to function properly, right? I mean, if I protection switch
that is correct.
Right.
Yeah, I agree. ngPON2 just breaks this.
That's well, and type B as well, and it's also a problem.
Yeah.
I mean, that's the choice of the OLT or whoever configured the OLT adapter in this case. If the person configuring the OLT adapters is saying pass everything down to the ONU, if it doesn't work with certain ONUs, that's on them. I mean,
well, no. I mean, if in a Type B situation,
I don't know what the Type B is.
Sorry, I'm basically it's a protection group for the PON. So basically, there's one OLT that is transmitting and receiving on the PON, and another OLT that is just receiving. It's not transmitting, and that's a standby OLT. So if the fiber fails between the active ONT and the splitter, then the standby OLT then is now transmitting and receiving. So there's no reconfiguration in that scenario. It just has to function when it switches over. It's supposedly a sub-50 millisecond protection on the PON.
Okay.
ngPON2 is similar, a similar solution as well, similar issue. Well, it's more complicated.
Okay, but so is your problem if you have 2 OLTs and they are not the same adapters?
Yeah, they're different adapters. So
the 2 OLTs that we all agree, OLT, the big box.
Yeah.
2 different ones.
Yeah.
Connected to one ONU, the same ONU with the protection group, you say?
Yes.
I mean, first of all, it's a very unlikely scenario that someone will deploy 2 different OLTs connected to the same OLU. I don't think optimizing for this scenario is much, I mean, it's very important. And second of all, if someone used one OLT that had some capabilities that cannot be used with the other one, it was a terrible operating decision, and it should not work. I mean, if the OLT, the primary OLT, is supposed to do something normal, S tag, C tag, and that's what it's going to be in most cases. It's going to say, I'm take care of the S tag, pass on the C tag to the ONU adapters for his OMCI, and it will work fine. It will work as long as the second OLT, the missing one here, is configured to do the same thing. So it's sharing the flows, I guess, or it's getting a set of very similar flows to implement the S tag. And that would work as long as they're both implemented correctly. I see your point that maybe we have 2 OLT adapters that implement flows differently, but it's better to give them strict definition of flows, like the most direct and most unfiltered coming from monos, and then have them implement them the way they can do it, the way they know they can do it, and then have the remaining go to the ONU.
Yeah, but then I think that there are existing standards around what the OLT does and the ONU does.
True.
Like,
yes. My point is not let's do something crazy with the OLT adapter. My point is more, if someone wants them to do something slightly crazy, give them enough room to do it. If we want to have the OLT adapter, instead of doing a S tag, do a layer 3 something, and it's deciding, okay, to do that, I'm going to match on one VLAN, and so I'm going to send this appropriate flow to this ONU. So it's going to come VLAN 20. I'm going to take VLAN 20 and transform into VXLAN, whatever, or to some IP and something like this. And it's not, I mean, this piece of it is no more different than when it was in the old model. The ONU was still receiving the flows. The difference is, yes, if the primary decide where flow is going to send and the secondary would have decided something different, they may not be aligned. But I don't think that's a scenario that is likely in any way.
Hi, this is.
I guess another consideration is what happens if the OLT adapter that's being used is closed source? How are we confident that that's going to work?
I mean, I don't see how it'd be different, because the OLT adapters just has to decide what it wants the ONU to do, and then the ONU does it.
Mm-hmm.
The OLT adapter gets in the logical flows, act on them, store what he wants to store. If he wants to store something proprietary and obfuscated, let it do that. It may not be good for the operators, so I don't think we're going to use it if they obfuscate it too much. But then, as long as it's honoring, I mean, it's sending the logical flows to the ONU adapter, then the ONU adapter is just abiding by it. Whatever, even if the ONU adapter is proprietary, if it's told, you put one C tag and you go, I mean, as long as it's doing what it's told, even if we don't know what it's doing because we can see inside, it's fine. And this side of it, the ONU side, is not much different from what it used to be. It was getting some flows and it was acting on those flows. The only difference now, the flows are more direct and maybe slightly different, but some ONUs may have more capabilities than others and so on. But if someone wants to use like an ONU with 50 gem ports or 50 VLANs at once, it has to choose the hardware and also the adapter appropriate to do so. So, and to me, most of the constraint of what if we send those kind of flows falls on whoever is deciding to use those devices and those adapters. They have to use some combination of them that do work to do what they want to do.
Hi, this is Amit. So the current flow decomposer does the decomposition in such a way that it assumes that the OLT is going to operate on the S tag and the ONU is going to operate on the C tag. So if any other model is to be supported, the adapters as of today don't have any flexibility because the flows have already been decomposed in the core in that way.
Correct. I agree 100%. There is currently no flexibility, and that would be a long-term problem.
Yeah, so for scenarios like when you would want the ONU to not add or whatever, not operate on the C tag, or for example, when you expect that you get double tag packets from the ONU itself, and the OLT passes them transparently. So those kind of scenarios are going to be tricky with the current decomposition that's happening.
In the current decomposition, I don't think it can be done. In the new decomposition, I think it can if you instruct the OLT adapter to not do the taggings, the two tags, and then pass all the flows related to tags to the ONU adapters, and this adapter can implement them faithfully, then it works.
Well, I guess somebody has to make that decision as to where the tagging occurs, right? I mean,
true.
And then that has to be common between two different adapters potentially, right? We have to account for that situation.
I mean, yes, and at the same time, not really, because if what you want to do is you say you create the flows to say I want traffic that is double tagged coming out of this, and it's going to be this tag and this tag for this specific uniport, which is currently what we're doing. No one really needs to know. I mean, it's more like it doesn't really matter for the traffic if the ONU is tagging it twice, or the ONU is tagging it once and the OLT is tagging it twice. It's tagging it the second time, or the OLT is tagging it twice and the ONU is not tagging it. As long as they can sort it out, who's doing what, as long as the OLT decide I'm taking in charge this piece of it, you take this charge this piece of it, and if we all do what we agree on, traffic flows the way it's expected to.
Well, as long as adapter one and adapter two know what the decomposition should be for any given ONU. I mean, there has to be a common understanding of the behavior of the system.
Okay, so to me, the flows going to the ONU in the regular case we all use today would be come in on your uniport, add a tag, value 20, and send it up your uplink, which is basically the flow. And the reverse flow, coming uplink, remove the tag and send it to your uniport. That's the flows that the OLT is likely to send the ONU. The regular case, it's this flow. It's a very simple flow, and the ONUs will all implement these flows, or at least should all implement this flow if they want to be used. And then there are more advanced flows, which some adapters may implement, some may not, probably depending on the hardware below it.
But doesn't the open flow message itself protocol define what happens on what interfaces, right? I mean, obviously it doesn't understand the PON interface. But
correct, but the OLT adapter will say that this port 16 or whatever of the uni, which is one of mine, which is on my PON port, I'm going to set the PON port to be able to connect this side of it and do this side of it and do the S tag, and I'm going to send the logical flow, the remaining piece, which is currently like the table 2 piece or the table 1, depending on which side you're going, to the ONU and tell him you do this, and then we're good.
Yes. So the open flow flow rules, they see only the uniport and the NNI port, and they are not aware that there is an intermediate hop in between, right?
Correct.
Yeah. So OpenFlow is not able to figure it out how to do that.
No, that's why the OLT adapters figure out that's my NNI port. I'm going to take care of this side. That's my PON port. I'm going to take care of this, and then take care of the S tag, and I'm sending the remaining, the C tag piece to the ONU, and the ONU is taking care of itself.
Well, I think maybe we need the product owner or the operators to weigh in on how they want this to behave. Do they want to control a standard way of doing the tagging, or do we want to just let the OLT adapt to do whatever it thinks is appropriate, right?
If I may just hook in here. This is Paul Wagner from DT. I'm a carrier, so I'm maybe can give an advice here. We have the case of the GFAS of a DPU, where we'll probably assume that there will be CTAG and STAG already put in at the DPU, that is the ONU part, and the OLT potentially only passes on this onto the NNI, so it does not do any tagging. And I would expect for some, from common sense, that you would need to have a distinction like this in this technology profile. Is that correct understanding?
Well, all the time right now with the technology profile, it doesn't deal with what the OpenFlow rules have. I mean, we could potentially make that more specific to add that option.
We could have some configuration piece, being technology profile or otherwise, that will instruct, I guess, the OLT, you do not do tagging, for example. So the OLT will just look at the flows and make sure that the NNI does what it's supposed to do, the POM port does what it's supposed to do, not do any tagging, or maybe do some other things, like if we have like layer 3 or something else, and then pass on to the ONU. The ONU look at it and say, okay, I do this, I don't do this, and pass it on to the DPU, which then the DPU does what it could do. So we could just add some configuration to those pieces and have them use it to vary who's taking care of which piece of the flows.
Well, I think in the Deutsche Telekom case, that flow decomposition is very simple. It's coming in on the UniPort double tagged and it needs to be trunked to the NNI. So that's basically a flow that goes from the OLT and the ONU that does nothing. It just basically trunks it. That's a very simple.
It can be derived from the OpenFlow messages, I guess. Right?
Yeah, right, Chip. So in this particular case, I think OpenFlow can clearly specify, because there's no ambiguity, as nothing changes through the OLT and ONU. Both of them work as transparent. The problem comes when something changes in between, but OpenFlow is not exactly able to specify that who is supposed to do this, because it doesn't know that there are intermediate guys in between who are doing this.
And the idea is that technology profiles deal with technology-specific things, so maybe that would be something we could think about adding to the technology profile. But I think we do. I mean, well, I think we need to have interoperability between OLTs, and we need to have, the ability to have the same behavior exhibited by different OLTs for Type B and for NG.2.
Yeah. Well, and also this a centralized flow decomposer, once it's fixed, everyone receives those fixes at the same time. I mean, as opposed to everyone chasing a new feature in their OLT.
One thing I'm just, yes, the interrupt between OLT and ONT. Right now we also introduced adapter, so that interrupt. I think we want to make sure we don't impair the interrupt goal, the hardware agnostic goal too, right? But however, if we have a common OLT adapter and a common ONU adapter in the future, will the concerns being addressed? So what I'm saying is, if we have one OOT adapter and then work with multiple majority of the OOTs hardwares, then would that be a way, sort of like, so everybody will function exactly the same? I think the goal is, that's my question back to Sean and Chip, right? So if we have a common OLT adapter, does it mean some other concern will be, even, I think the chance Type B protection using two different hardware OLT adapter, I think that chance is pretty low. But however, there may be some chance on that. But if we have a common OLT adapter, would that cover, two different OLTs case?
Well, I think there are current broadband forum interoperability standards that you potentially will not pass, right? That would be one case, right? If you have a closed environment OLT ONU, then standardization may be an issue. Interop with one vendor's OLT and this disaggregated solution, the CBER, might be an issue. But I don't think maybe the operators can guarantee that you would only have an open OLT and an open ONU functioning, right, for all their OLT interfaces. I mean, it depends how important, what the priority, I guess, the operators give to interoperating between an OLT and ONU that are not the standard open OLT implementation adapter and the standard ONU adapter. Right? I mean, if you had a Nokia solution interoperating with, the SIBA solution, I mean, is that an issue?
First of all, I think, yes, broadband forum interrupt. I heard that, and or FSAN interrupt, right? But at the same time, I would like to have an operator-driven standard or approach versus vendor-driven. So I do see SIBA and VOLTHA as very operator-driven approach. But again, I'm not going to block everybody out for by making any of the comment like that because our vendor community has been doing a lot of great job for the VOLTHA community. But I do think the goal is we want to make sure we have a framework can provide hardware agnostic and device agnostic approach, right? I think that's the goal or bylaw of the VOLTHA. So I'm not making any position regarding to this, but I think Nick is ready to do some demo.
Yes.
So let's take a look at that, and then I do want people to address interrupt issue. I think we want something interrupt can be established. So is that okay? Let's go forward. I mean,
yep.
Go forward with the demo.
So I have two set of VOLTHA and OLTs and such. One with the current model and one with the model I'm proposing. So if you look, so this one is the current one. We have one OLT, one ONU. So I'm going to show the flows on this one. So we have those flows currently. We have those, so the E flow, and we have this flow, which is somewhat undetermined. So to trigger the E, I'm gonna reboot this. It's gonna take 30 seconds. In the meantime, I'm gonna show you this side of it. So same one ONU. So we have those flows. I'm surprised about this one, to be honest.
And the device still shows reachable. The ONT device. That's the same ONT you're rebooting.
It is reachable. You need to check something. What's the? Do I have the right image? What is it? Yeah, it's a problem with demos. Never works.
Well, it only works when you're not sharing your screen.
Exactly. Oh, that's why. Which flows? for flow. I'm gonna have to restart this. Sorry for the interruption. So in the meantime, I'm gonna see how this one is doing. So I want to show that on ONOS it has not been, but okay, the EAP didn't work, so I'm just going to add it manually for now to show flows. So those are the flows, the classic ONOS flows we see. So with the EAP flow, and then we have the two-way in and down. That's the flow we see in VOLTHA. So that's the EAP flow. We have this 4,000 that comes somewhat out of nowhere. We have this metadata. We have this VLAN 16, which also comes out of nowhere, which is linked to the port it's used for the linkage in the flow decomposition. This VLAN 20 is the one we pushed, and this 11 is the S tag. The bits and pieces that don't match and don't quite match reality. And you see we have 5 flows. In this case, it might take a bit of time to have it enable. But in this case, that's why you take screenshots to not have to do demos. So in this case, you see we have more flows because the way OpenOLT decomposed those flows, it results into more flows. For example, the EAP flows result into 4 flows. There's not only we need one up, we also need one down for some reason, otherwise the packet down doesn't go. And we also need to redo this one with another VLAN. We do it twice, one with the default VLAN, the 4091, and one with the actual VLAN for the subsequent EAP request. Okay, getting activated. With this, it should trigger the EAP. Let's hope this works this time. So see the setups. Okay, so the ONU is coming back. Now turn active in a few seconds. Okay. Now the EAP flow is set up, and it should be triggered very soon.
Are you using the NAM to have the whitelist?
No, I'm just using it directly. But I'm using a real RG, so I cannot force the EAP. It's on the timer.
Do you remember what's the model the model of your RG is 599 or 28?
I don't know.
Okay. I'm just gonna find.
Yeah, I'm just gonna add the flow manually to 1620. Okay, so same set of flows in both cases. The difference is more in the flows over here. So those flows, so you see we have more. I'm going to try to show two at once. This one. So in the current model, that's the decomposition we get. And those flows are then reinterpreted by the adapter into another set of flows, which are more like this. So the problem is we actually have 8 flows and we see only 5, which is a problem for troubleshooting. We don't know what went wrong. We just know we had those 5 flows that were supposed to be added. We don't know what was added. And in this case, now we know we added those 8 flows. If one flow fails, it's not added to the system. So you know you have only 7. So that's what you get by using the adapter decomposition. You have a way cleaner picture of your flows. You know you have 2 heap flows, 4091, one going up, one going down. Same heap flows with the VLAN 20. The VLAN makes sense. So 4091 and 20 and 12, which is the S tag. The IP protocol for the DHCP, you see that we have 2, one coming up, one coming down. Set VLAN and so on. Whereas those flows, we have plenty of set VLAN 4000, which have no basis for reality. And nothing real is happening with this 4000. We have those pop VLAN. We have 2 that pop VLAN. We don't really know why. I mean, the decomposition is fairly meaningless, and it's out of touch with the actual physical device. And that's the piece I'm trying to solve.
So I like seeing the actual real flows. I think one of the outstanding questions around the workflows is once I discover an ONU uniport and that gets reported to ONOS and a subscriber record is looked up, right? So once we have the subscriber record, we actually know what the real service tagging should be, right? So in theory, we don't really need to use this unknown VLAN tag for the authentication flows to go, right? We could actually use the real tags, right? So I mean,
admittedly, yes, if we provision the ONU from the start. But,
yeah, so I mean,
in the current model, we wait for the heap to be triggered to assess if this person is really this person.
Yeah.
The problem is at start we don't know who that is. It's on a PON port of 64 ONUs. We have a new ONU coming in. We don't know what VLAN to give it.
No, but
we don't know who it is yet.
Yeah, but we know what subscriber should be on that.
No,
point.
We cannot distinguish one of those 64. We just know who subscriber is supposed to be on the PON, but we cannot know if a new ONU plugs in. Oh no, yeah, we get the serial number. We get the
we need this, yes. Yeah, right. So we match serial number or registration ID, whichever way it is, right?
No,
so in theory, we do have, and I have a outstanding question on the workflow on this as well, is that we can use the real tag once we identify the the match serial number match or registration ID match. So some of this ambiguity may go away if we choose to use the real subscriber tag.
But still, though, you see that you have one heap on this side, and here you have 4. I mean, especially even if in those cases you have 2, because we need 2 flows. If you miss one, it doesn't work.
Nick, I have a point here. So the only difference that I see between the two is that the flows for the packet out, right? Those are also listed in the decomposition that you have done at the adapter. So import as controller, those are also listed, which is not listed in the older decomposition.
Okay, I understand how it can be confusing. Those are somewhat different flows, those coming from controller. They're not quite, I mean, there are flows you have to pass the OpenOLT for it to really act on those packet out. If you don't pass this flow, the packet out will not work. You get the packet in with this one, but you do not get, when you send the packet out, the response, there is a matching problem in the physical device. So that's why we have to add another one to allow this to go down. And to show that we do this, I decided to put the import as controller because that's where the packet's going to come from. It's not going to be coming from any physical N9. That's why we have this.
And just a time check, we've got about 2 minutes left before we're out of time for today. So we may have to continue discussion offline.
This may be a very special, stupid comment, right? I think at one point people actually complaining about we have too many flows with the original model, so it was 5, and now we increased to almost, to 8 flows. Would there be any the flow update issues or capacity issue will be encountered, and including potentially the message back and forth device?
No, but the fact that you have 5 flows stored over there, or you have 8, is, I mean, that's just database related. Mm-hmm. That's it. But in reality, in the physical OLT device, you have 8. You don't have 5 or 8. You have 8. That's not up for discussion. We send 8 flows. So in this case, we store 8 flows to track them. That could also help to do the delete. So just very quick, I'm doing this one. If you do remove, we're going to hope that, not cursed like the demo. That's the one. You can remove those flows. They are removed from Monos, and it's trickled down because since you can track them down, the actual flows you've pushed, so you know how to remove them.
I do like just like whatever display means something. So operation, if they need to do a diagnostic or look at whether the flow is there, it shows the actual state, either the flow is there or the flow is not there. So for the operation, I think this new approach is the right approach. But I'm still concerning about the interoperability between ONT and OLT. So
we don't lose any interoperability that we had before. If we lack interoperability, we just didn't have it before, and we still don't have it. Because the ONUs still get some flows the same way they were getting some flows before. Mm-hmm. This fact doesn't change.
And we're at our time limit for today, so I think I'll probably have to break the discussion at this point. So Nick, one quick thing for follow-up: if you could send those diagrams on VOLTHA Discuss so that the other folks look at them offline, that would be great. I think Sean, probably on the product owner side, may need you to get together with some of the service providers and pull together some material and use cases and other things as input and feedback, and all the interested parties and developers and engineers can continue the discussion on VOLTHA Discuss also. I think that would be a great benefit. Ultimately, this may end up having to be something to go to TST to make a decision on different trade-offs that we have here. So with that, I think we're out of time. Any last comments from the group before we drop the bridge for today? I think we'll need some follow-up discussion.
I do have a quick question. So I have a patch, outstanding patch for this, which create a different class of device that accept direct flows. So to do just this, it is fully backward compatible. Could we accept the patch and just use this as a proving ground? That could be our proof of concept of the concept of this direct flows. We can show that it works with OpenOLT, and then maybe it could help convince people that it's a better or it's a terrible idea, depending on if it crash and burn at the end. The removing of flow is using this significantly. So if we want to have flow removal, this is a very simple, way simpler way to go around it. And the flow removal is the underpinning of many other issues we are trying to solve.
One thing Nick, what this ONF was not at the call this time, so I'll socialize this with ONF, unless I don't think you have gone through this one with Shad or Jonah, right?
Yes, I did talk to Shad and Jonah about it. So Jonah, when he was at the office, he was okay with it in the concept. Shad too. So Shad +1, my comment was just waiting for the community. I get mostly like Ken and Chip to look at it and see.
What's your do you have a Jira number on this one?
Yes. 11:15 or 11:14.
Yeah, I guess I should know that.
11:15. Yeah. And I have a Gerrit patch to it.
Yeah. Julie, I think I'll do that, and then I think once Nick posts the diagram, I do welcome people to provide feedback on the VOLTHA discuss.
Okay, and I think we will have to break here for today because we're a bit over. So I will go ahead and drop the bridge, and then we'll post a recording later so people can review it as well on YouTube if they need to for the presentation. Okay, thank you to Ken for your presentation also. Thank you, Nick, for your presentation, and to the team for the discussion. And we'll have to follow up on this one later, but I think we have some homework actions for a number of folks afterwards for review of this and for collecting some additional info from service providers and so forth. With that, I think we'll wrap up the call today. Any last comments before we drop the bridge? Okay, thanks everyone.